Good morning, everybody. We continue working on slopes of straight lines. Slope of a straight line is a property of a straight line. It determines or describes the steepness of the line. It determines how does a line go from one point to another point. Two different points determine a straight line. If we have two different points of a line, then we are able to find the slope for the line. We have the formula on the board. We learned the formula yesterday, right? And the end of the yesterday, I give you the second problem, ask you to work on your own. Anybody have the answer? Did anyone work on this problem and have the answer for the slope? We did the first problem together, right? We apply the formula. Slope m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. The slope of the straight line passes through negative 1, 3 and 0 and 1. 0, 1 is negative 2. Slope is negative 2. The straight line goes down, right? When we look at a graph from the left to the right, the straight line goes down. We mentioned that's the first conclusion. And second problem, let's work on this together. I'm going to apply my 3 steps procedure to find the slopes for the line passes through those 2 points. I firstly label the 2 points. Be careful, you label the point x sub 1, y sub 1, or x sub 2, y sub 2. Please do not label a point as x sub 1, x sub 2. That is very creative, but incorrect. We know every point has 2 coordinates. The first component is the x coordinate. The second component is the y coordinate. We label the first point x sub 1, y sub 1. Second point x sub 2, y sub 2. So we have x1 equals negative 2. y1 equals negative 4. x2 is 0. y2 is 2. Right? What's the second step? Do you guys remember? Copy the slope. Copy the slope formula. Slope m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Step 3, plug in the values in the formula. Please do what I do here. Use parentheses to frame. Use parentheses to hold a place for those variables, and then put the values in the parentheses. In the numerator, what's y sub 2? Numerator, what's y sub 2? Look at here. What is the y sub 2? 2, yeah, so you have a 2 here, right? What's y sub 1? Negative 4, so you put the negative 4 in the parentheses. Denominator, what's x sub 2? 0. What's x sub 1? Negative 2. Tell me please, what's the numerator? 2 minus negative 4. 2 minus negative 4. Yeah, minus negative 4 is plus positive 4, right? 2 plus 4 is 6. Very good. Denominator, what's 0 minus negative 2? Minus negative is the same with plus positive, so it's 2. Reduce, what's 6 over 2? 3, yeah. In this case, the slope we got for this straight line is a positive 3. Let's graph the line in the rectangular coordinate system. Let's see the first point, negative 2, comma, negative 4. X coordinate is a negative 2. Y coordinate is a negative 4. Which quadrant this point is at? Quadrant 1 or 2 or 3 or 4? both x and y are negative. Quadrant 3, yeah, exactly. So it's to the left of origin 2 units, below the origin 4 units, 1, 2, 3, 4. So the first point is in quadrant 3 right here. 2 units to the left, 4 units below. Second point, 0, 2. Where is this point located? Quadrant 1, 2, or 3, or 4. Notice the x value. X coordinate is 0. Yeah, where is this point? Yeah, 2 is on a y-axis. All right, it's on a y-axis. Now let's see the x coordinate is 0. X coordinate describes the horizontal displacement. If the x coordinate is 0, means horizontally is not to the left of the origin, not to the right of the origin. So of course it will not be on the y-axis. So it will be on x-axis. It is on the y-axis. All the points on the y-axis is not to the right, it's not to the left of the origin, right? It's on the y-axis. Y coordinate is 2. So the point is 2 units above the origin on the y-axis. So 1, 2. That's the second point. Let's connect the 2 points. 2 different points determine a line. This straight line corresponds to the straight line passes through the given 2 points. All right, look at the slope we got earlier. Slope is a positive 3. And look at the straight line, the graph of the line. Remember, you look at the graph in algebra from the left to the right, not the other way around. Yeah, you look at the graph from the left to the right. Is the line going up or going down? Is the line going up or going down? Going up, yeah. When you look at the straight line from the left to the right, the line is going up. Slope is positive. That's the second conclusion we need to remember. For a straight line, if the slope is positive, then the line goes up. Vice versa, if we have a straight line going up, then the slope of the line is positive. Let's go back to the first conclusion. The example we had yesterday. Slope is negative, right? The line goes down, right? Vice versa. If the line goes down, then slope is negative. Yeah, I want you to combine those 2 conclusions together. For a straight line in a rectangular coordinate system, if the slope is positive, the line goes up. If the line goes up, the slope is positive. If the slope is negative, then the line goes down. Vice versa, if the line goes down, then slope is negative. All right? We have another 2 conclusions. We have 4 conclusions in total about the slopes. Then let's see this example. Find the slopes for the following 2 straight lines. Let's see number 1. The equation is x equals 2. Determine if x equals 2, a linear equation in 2 variables. Yeah, we had this covered at least twice. I want to see if you remember that. Tell me please, is x equals 2, this equation, x equals 2, a linear equation in 2 variables? Obviously, the variable y is not in the equation, right? You don't see y in the equation. Yes or no? X equals 2. Is x equals 2 a linear equation in 2 variables? Yes. Y does not appear because the coefficient of y is 0. Right? Do you see that? Coefficient of y is 0. Yeah, this is also a linear equation in 2 variables. So this equation corresponds to a straight line in the rectangular coordinate system. What kind of straight line do you guys remember? Do you guys remember? What kind of straight line x equals 2? We had this covered yesterday. Yeah, we graphed this line. Huh? Vertical, horizontal? Vertical or horizontal? Vertical, yeah, exactly. X equals 2 is a vertical straight line, okay? You must remember in a linear equation in two variables, if the equation has no y, in other words, the coefficient of y is 0, then the equation represents a vertical straight line. Let's graph the line. This is origin, x-axis, y-axis. Do you guys remember how do we graph x equals 2? X equals 2. So on the x-axis, from the origin, we go to the right 2 units, and then draw a vertical straight line here, right? You see that? Yes or no? So far so good? Yeah, what are we doing right now? We are looking for the slope of the equation. We are looking for the slope of this straight line, this vertical straight line. In order to do that, we want to find the 2 points. Yeah, we have the formula. We have the formula for finding slope of a line if we know 2 different points on the line, right? How about let's find 2 points on the vertical line. Yeah, this one, the black point on the x-axis, that is 2, 0, right? Do you see that? The point above it is 2, 2. Do you agree? Those 2 points are on the line, right? Yes or no? Okay, so the 2 points are 2, 0 and 2, 2. We got the 2 different points on the vertical straight line. We are looking for the slope of the line. So we are going to apply the 3-step procedure again here. Step 1, label the 2 points and label them as x1, y1. This is x2, y2. So we have x1 is 2, y1 is 0, x2 is 2, y2 is 2. You see, I always have this part. The values for the 4 variables. Step 2, we are going to copy the formula. Slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Step 3, plug in. Plug the values in the parentheses. We see this earlier, right? We saw this earlier. Tell me please, what's y sub 2? Y sub 1. X sub 2. X sub 1. What's numerator 2 minus 0? 2, right? 2 minus 0 is 2. Denominator, what's 2 minus 2? 0. Okay, use your calculator. Tell me what the calculator tells you when you divide 2 by 0. If you divide 2 by 0, what do you have? The calculator probably tell you error, right? Yeah, that means this is undefined. Undefined. Denominator can never be 0, right? This number does not exist. So here we have the third conclusion here. We have the third conclusion. If we have a straight line, the line is vertical, then the slope of the line is undefined. Vice versa. If the slope of a line is undefined, then the line is vertical. By the way, the only correct way to describe the slope of a vertical line is this word, undefined. Please do not be creative. Don't say does not exist, infinity. Those are incorrect, okay? The only correct way to describe the slope of a vertical line is this word. What's this word? Undefined. Let me repeat the third conclusion, yes? The other point that we found, take that? Yeah, and randomly take that point. You can try other points. For example, you can try 2, 5. It won't matter. because the numerator will always give you a non-zero number. Denominator always be 0. And no matter which 2 points you pick on the vertical line, the x coordinates of the points are identical. In this case, all the points on the vertical line, their x coordinates are 2, right? Yeah. So when you calculate, when you plug in the formula, the denominator x2 minus x1 is the difference of the x coordinates of the 2 points. It will always give you 0. Yeah. So it doesn't matter what's in the numerator. If the denominator is 0, then the slope is undefined. That's the third conclusion. Remember, we have 4. Let's see the last one. Let's see how do we find the slope for this equation. Equation y equals -5. Tell me please, is y equals -5 a linear equation in 2 variables? We have been talking about this chapter for a few days, right? Yeah, the focus of this chapter is a linear equation in 2 variables. And I showed you linear equation in 2 variables in rectangular coordinate system is a straight line, right? Look at this equation and tell me, is this equation a linear equation in 2 variables? If I write this equation as 0 times x plus 1 times y equals 95, it is in the form ax plus by equals c, right? Yeah, a and b are not both be 0. This equation is a linear equation in 2 variables. The reason you do not see variable x is because the coefficient of x is 0, right? So this is a linear equation in 2 variables. Then this equation represents a straight line. What kind of straight line this equation corresponds to? What kind of straight line do you guys remember? Horizontal, awesome, exactly. Horizontal straight line. Let me graph it here. In a rectangular coordinate system, y equals -5. Look at the y-axis, the vertical scale. Find the origin. Since y equals -5, start from the origin, go down 5 units. 1, 2, 3, 4, 5. And here you're gonna draw a horizontal straight line. Okay, horizontal straight line. Bless you. Y equals -5 is a horizontal straight line. We are going to find a slope for this horizontal straight line. We have the formula to compute the slope for a straight line, right? But we need 2 points. We need 2 different points. How about we take this point? Because this one is the Y-intercept actually, right? This point is 0, 95. Do you agree? Can you pick another point for me? It doesn't matter, any point would be okay, as long as the 2 points are different. I got a 1 because that's obviously 0, 95, right? Can you find another one? 0, and that's not on the line. You mean -3, -5? All the points on the line have y coordinate -5. You're gonna know. Huh? Yeah, you pick a point on the red straight line. Because we are looking for the slope for the red line. You can just point it where I have 1 point already. How about here? How about here? It doesn't matter. Whichever convenient for you. How about here? What about here or here? Any point on the line. Any point would be okay. Huh? Well, as long as it's different from this one, we have many points. 95? 4 doesn't work. You know, the point on the line the point on this horizontal straight line, I'll have a y coordinate equal to 95. Okay, let me show you. This point is 0, 95, right? This point is 1, 95. Do you see that? And this point is 2, 95, 3, 95, 4, 95, 5, 95, and so on and so on. This point is -1, 95. This is -2, 95, and so on and so on and so on. Do you see that? Yeah, that's good. That's a good choice. 395 is a good choice in quadrant 4. 1, 2, 3, 95. So this point is on the horizontal straight line. The coordinates of this point is 3, 95. Very good. That's a good choice. Let me write the 2 points we found. The first point, 0, 95. Second point, 3, 95. Let's use the formula we learned yesterday to find the slope of the line. Step 1, label the 2 points, x1, y1, x2, y2. Yeah, I would not mind to write the values for the 4 variables here. x1 is 0, y1 is 95, x2 is 3, y2 is 95. Yeah, it won't take you too much time. You're going to look at it here later when you plug in values. Step 2, copy the formula. The formula will be on the board the whole semester. Slope of straight line m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Step 3, plug in. Yeah, please. Even I emphasize this so many times. Please use parentheses first and then plug in. I don't know why, but some students they just don't do that. If you don't do that, very likely you'll make a mistake. You have those parentheses hold a place for those variables, reduce the possibility you make the mistake. Okay? Yeah, use the parentheses first, and then put the values in those parentheses. Tell me what's y sub 2? Y sub 2? 95. What's y sub 1? Yeah. Denominator, what's x sub 2? 3. What's x sub 1? 0. Okay. Numerator, what's 95 minus 95? Yeah, don't think it too complicated. What is 95 minus itself? 95 minus itself. A number minus itself. What is it? 0. Thank you. Denominator, 3 minus 0 is 3, right? Okay. What is 0 divided by 3? 0. Yeah. 0 divided by any non-zero quantity always equals 0. All right, that's our that's the fourth conclusion about the slope. If the slope of a line is 0, then the line is horizontal. Vice versa, if the line is horizontal, slope is 0. This actually is consistent with our common sense, right? The straight line is horizontal means it's flat, right? It's flat. So slope is 0. Yeah, by the way, in real life, sometimes you say, this is flat, so no slope, which is incorrect in algebra, okay? Again, the only correct way to describe the slope for a horizontal line is the slope is 0. It does have a slope. The value of the slope is 0. The value of the slope is 0 does not mean it does not have a slope, okay? Yeah. So this is the number 4 conclusion. Let's put all the 4 conclusions together. This one, slope is negative, line goes down. Slope is positive, line goes up. Again, you look at the graph from the left to the right, okay? If you look at it from right to the left, it's going down, it's straight line. But if you look at it from left to the right, it's going up. If the line is vertical, slope is undefined. If the slope is undefined, line is vertical. If the line is horizontal, slope is 0, Vice versa, if the slope is 0, line is horizontal. Yeah, look at this table. This table includes the 4 conclusions we mentioned earlier. Summarizes the 4 cases for slopes of the lines. Look at this, what's the color? I can't tell. Look at this green. Green, purple, blue, red. Yeah. Look at this green line. It's going up, right? Slope is positive. Vice versa, slope is positive, line going up. Look at this purple line. Slope, straight line going down, slope is negative. Slope is negative, straight line goes down. This one, slope is 0, so the line is horizontal. Line is horizontal, slope is 0. This one, slope is undefined, so vertical. Line is vertical, the slope is undefined. Okay? Yeah, why do we need this? Need to learn this. When you take the test, all my questions are multiple choice questions, right? So if you know the slope is positive, when you look at the 4 graphs you are given, you will not choose the one going down. Do you see what I'm talking about? Yeah, that helps you to make the correct decision when you work on the multiple choice question. If you already have the slope is positive, you do not choose the line going down, right? Obviously, that's a contradiction. Am I clear about that? Yeah, you need to remember those 4 conclusions. What kind of straight line has a slope 0? What kind of straight line has a slope of 0? What kind of horizontal? Yeah. What kind of straight line has a slope undefined? Vertical. Very good. Now we can move to the next section. 3.4. 3.4. 3.4. Give me 1 second. Let me write the formulas on the board. We are going to learn 3 forms of linear equivalent variables. So far, we have learned 2. So we're going to write it here. Linear equations in two variables. Linear equations in 2 variables in rectangular coordinate system are straight lines, right? And it has 3 forms. Form 1 is the standard form. Standard form. The formula for standard form is ax plus by equals c. Here, a and b are not both 0. Number 2, the second form is the one we're learning today. Is the slope intercept form. Slope intercept form. The formula for slope intercept form is y equals mx plus b. M is the slope. 0, b is the y-intercept. We learned intercepts yesterday, right? And number 3, we're gonna probably learn probably next Monday. Corner slope form. We don't learn this form today. Yeah, but let me run it here. So y minus y sub 1 equals m times x minus x. That's good. M is the slope. X1, Y1 is a point. Today we're gonna learn the second form. Before we learn the first form already, right? The beginning of this chapter, we learned the standard form. Ax plus by equals c. Today we are going to learn the second form of linear equation in 2 variables. It's called the slope intercept form. Okay, let's look at the form, and I highlighted in blue here. Y equals m times x plus b. This formula is the slope-intercept form of a linear equation in two variables. So this formula gives us the slope-intercept form of a straight line in a rectangular coordinate system. Let's look at this formula carefully, okay? Let's look at this formula. It's an equation. The equation has two variables, x and y, right? The exponents on the shoulder of the x and the y are 1, so it's a linear equation in two variables. Yeah. Some important features or characteristics of this formula is on the left of the equation. On the left, we have a variable y isolated. Yeah. What does the slope-intercept form of a straight line look like? The left-hand side of the equation is y, only y. Y is isolated on the left, right? On the right, on the left is isolated. On the right, we have mx plus b is a linear binomial. Yeah, we haven't learned that yet. We learned that in chapter 4. It is m times x plus b. So we see two constants here, right? Besides x is a variable. M and b are numbers. Yeah, those two numbers have meanings. M here actually is the slope of the straight line. B here actually is the y coordinate of the y-intercept of the line. That's the reason this form is called a slope-intercept form, because the equation contains slope and y-intercept in the form. Okay, yeah, we need to remember that. We are not going to prove it. I can show you quickly why B is the y coordinate of the y-intercept. Yesterday we learned intercepts, right? Do you guys remember the definition of a y-intercept? What's the definition of a y-intercept? Y-intercept is the intersection of what and what. It's a point, right? Y-intercept is a point where the straight line crosses what? Look at your notes, please. Look at your notes, please. What's the definition of a y-intercept? Ian, what's the definition of a y-intercept? Chapter 3 is pretty challenging, by the way. What is a y-intercept? I'm waiting. Y-intercept is a point. At that point, the straight line crosses with the y-axis. Okay? So the y-intercept has an x-coordinate 0. How do we find the y-intercept? Remember that yesterday? When we find the y-intercept, we make x be 0, right? Yeah? Okay, in this equation, the slope-intercept form, make x be 0, make x be 0. So this is disappear, right? You make x be 0, m times 0 is 0, right? So what is y? Y equals what? Y equals what? B. Yeah. So 0 comma b is the y-intercept. So I showed you quickly why b is the y-coordinate of the y-intercept. M is the slope. I'm not going to prove it here. Just remember the coefficient of x on the right-hand side of the equation in the slope-intercept form is the slope. Okay? All right, let's practice. We learned slope-intercept form. Slope-intercept form of a straight line is y equals mx plus b. We're going to do a practice. We're going to do a practice. All right. Look at the first equation. Y equals 1 over 3x minus 5. Look at the equation. Determine if this equation a slope-intercept form of a straight line. The formula is right above it. Yes? Okay. If yes, you tell me what's the slope. Tell me what's the slope. For the first one, what's the slope m? Huh? Yeah, exactly. It's the coefficient of x on the right hand side of the equation, right? And what's the y-intercept? Again, don't tell me a number. Y-intercept is a point. So it's 0, comma a number. What's the number? What's the y-intercept? 0, comma 95. Yeah. Are you guys all right today? Are you guys all right today? Angela? Number 2. Look at this equation. Y equals x plus 10. Y equals x plus 10. Determine if that equation represents a straight line. If that equation gives us a straight line in the slope-intercept form. So today we learn slope-intercept form, right? Yeah. Does that represent the slope-intercept form? Yes? Sammy? Does that represent slope-intercept form? Okay, tell me what's the slope? 1. Did you see that, everybody? Okay. What's the y-intercept? 0, comma 10. Hello? Are you guys with me? Y-intercept is 0, comma 10, right? Very good. Let's see number 3. Determine if this equation a linear equation in two variables in the slope-intercept form. Y equals negative x plus 3. Y is isolated on the left, right? Tell me what's the slope? Negative 1. Okay. And what's the y-intercept? 0, comma 3. Okay, very good. Number 4. Determine if that equation y equals x, a linear equation in two variables, and what form that equation is. Y equals x. Is that slope-intercept form? Yes? If yes, what's the slope? 1. Yeah, slope is the coefficient of x, okay? What's the y-intercept? What's the y-intercept? 0, comma 0. Yeah, 0, comma 0, okay? So this straight line passes through the origin. That's the first practice. We are given a linear equation in two variables in the slope-intercept form. We identify the slope and y-intercept from the equation. Next practice, we're going to do the other way around. I'm going to give you the slope and the intercept, and you write the equation of the line in the slope-intercept form. Am I clear? So this practice, we are given the straight line, right? In the slope-intercept form, you identify slope and intercept. Next up, we're going to do the other way around. I'm going to tell you the slope and the y-intercept. You write the equation of the line in the slope and in the slope-intercept form. So this time I give you m equals negative 2. Y-intercept is zero, comma negative 10. All right? Yeah, if I give you the slope and y-intercept, can you write the equation of the line in the slope-intercept form? Let me give you the formula. Formula is y equals mx plus b. Yeah. What's the equation of the line whose slope is negative 2, whose y-intercept is 0, comma negative 10? Huh? What is it? Huh? Y equals negative 2 times x, and then minus 10. Do you see that? Is that doable? So you just plug in m equals -2, right? And where do you find your b? This is your b. The y coordinate of the y-intercept is the b. Is that doable? Let me give you another one. Slope is 1. Y-intercept is 0,3. How do you write the equation of the line in the slope-intercept form? Huh? Y equals 1 times x plus 3, right? Yeah. So 1 times x, sometimes we do not write 1. So it's just y equals x plus 3. Does that make sense? From those two practice, we get us familiar with the formula. And the formula is y equals mx plus b. That's the second form of a linear equation in two variables. The first form we learned is called a standard form, right? The standard form is right here. ax plus by equals c. Next example, we're gonna see if we are given the equation in the standard form, how do we rewrite the equation in slope-intercept form? Okay. So example, let me label this example 1. Let me see. Example 1. Rewrite the equation in slope-intercept form. Okay? Rewrite the equation in slope-intercept form. Let's see how do we process this problem. We have 3 parts. We have 3 equations here. The first one, we got an equation 3x plus 4y equals 9, right? The equation is in the standard form. Let me write a formula for standard form. ax plus by equals c. So obviously the equation is in the standard form, right? Yes? Okay. We are going to rewrite the equation in the slope-intercept form. How do we do that? How to rewrite the straight line in the slope-intercept form. We solve the equation for y. Okay? Yeah, the answer is we solve the equation for y. In other words, we are going to isolate y on the left. Okay? Let me repeat what are we doing right here. We are going to rewrite the equation of the line in the slope-intercept form. The equation we are given is in the standard form right now. Yeah, we're gonna convert it to the slope-intercept form. How do we do that? It's easy. Solve the equation for y. Solve this equation for y. In other words, we are going to isolate the y on the left of the equation. Yeah, let's see how do we do that. So this is very important. You are going to isolate the y on the left. Isolate the y on the left. Let's see what's on the left right now. Right now on the left, we have 3x plus 4y. That's a lot, right? Yeah. So could we move this term 3x over? Huh? Remember my transposition of terms. Could we move 3x over to the right? You move it and change the sign, right? You change the sign, what sign? Negative or positive? Negative. 3x in green is a positive, right? After you move to the right, you got a negative 3x. You bring down a 9. You bring down a 4y. Okay, let me show you what happened here. What happened here is we moved 3x to the right-hand side. We apply the transposition of terms. We move it when we change the sign, right? See that? If you don't like this method, do this. Let's say you have 3x plus 4y equals 9. You want to get rid of 3x from the left-hand side, right? What you can do is minus 3x from both sides. From both sides, right? And they cancel. Then you have a 4y on the left. You have negative 3x plus 9 on the right. You got the same thing. But seriously, I really think my transposition of terms is more convenient. You don't have to write those things. You can just move it over and change the sign, right? Move it over and change the sign. All right, we are isolating y. After we move 3x over to the right, on the left we have a 4y, but we want a y by itself, right? How do we get rid of the coefficient of y, which is 4? How do we get rid of coefficient of 4? Divide, plus, minus, divide, multiply. We're going to divide by 4, right? We are going to divide everything in the equation by 4. Divide this by 4, divide this by 4, divide this by 4. We have 3 terms in total, so we are dividing all the 3 terms by 4. 4 over 4, 1. So we have a y isolated. On the right, we have negative 3 over 4x plus 9 over 4. And that is the equation of the line in the slope-intercept form. Do you see that? Tell me, please, what's the slope? What's the slope of the line? Negative 3 over 4, very good. What's the y-intercept of the line? 0, 9 over 4, right? 0, 9 over 4. Do we see that? Slope-intercept form, okay? Yeah. Why do we need we have the standard form is not that enough. Why do we have to convert it to slope-intercept form? You might already see the benefit or the advantage of slope-intercept form. Because we are able to identify slope and y-intercept directly from slope-intercept form. We cannot do that if the equation is in the standard form, right? It does have its advantage. How about you do the second problem? The second problem is x minus y equals 0. Yeah, that equation is in the standard form as well. Can you please rewrite the equation in the slope-intercept form? To do that, simply just isolate y on the left. Isolate y on the left. Take your time. You have to isolate the y on the left. If you have a negative y on the left, what you can do is you divide both sides by negative 1. Divide both sides by negative 1. In this case, the coefficient of y is negative 1, right? Earlier, in the first column, the coefficient is 4, so you divide both sides by 4. In this case, the coefficient is negative 1, so you divide both sides by negative 1. You got a y equals x. That's correct. Then you do graphing.
Good job. Very good. You got it? Perfect. The equation right now is in the standard form, right?
Let's isolate y on the left to get a equation in the slope-intercept form. We can bring this term over, can we? We bring negative y down. We call it 0. We bring x over, so we have negative x. You see that? You see that? And then you divide both sides by negative 1. You have y equals x, right? I can show you another way to get this job done. We have x minus y equals 0. The easy way is this time you bring y over. You bring y over, you have x equals y, right? Negative y is negative on the left. When you bring it over to the right, you have a positive. And then you switch the size of the equation. You have y equals x, right? Yeah. Let me write the formula of the slope-intercept form here. Y equals mx plus b. And tell me what's the slope and the intercept? Y-intercept. Yeah, we did write the equation in the slope-intercept form. Can we identify the slope and the y-intercept from the equation, from the form? What's the slope? 1. What's the intercept? Y-intercept. Comma 0. Yeah, good job. Very good. Perfect. Do another one. Number 3. The equation is x plus 2y equals negative a. Okay? The equation is in the standard form now. Convert the equation in the slope-intercept form, and identify the slope and the intercept, y-intercept. Take your time. Try just isolate the y on the left. Isolate the y on the left. Do you have an answer? Write the equation in the slope-intercept form. How do you bring the x over? You have negative x on the right hand side, right? And you divide both sides by 2. And what about this part? You have to bring it down. Yeah. You're right. You just bring it down. A over 2 is 4, so negative 4. Yeah, very good. And what's the slope? What's the y-intercept? Yeah, sure. You have an answer? So your goal is to isolate the y on the left, right? So do you want to get rid of this term? You can bring it over. Yeah, minus x. you're bring x over. So it's 2y equals negative x plus negative x minus a. 2y equals negative x minus 8 equals negative x minus 1 minus 8. Yeah. What you just did is you bring x over, you move it over to the right. So you positive becomes negative, right? You are isolating y, so that's why you need to get rid of this term on the left, right? You did it. And now you're gonna get rid of the 2 here. How do you get rid of the 2? Yes, divide everything by 2. Everything. You have to treat everybody in the equation the same way. Very good. That actually is a negative half times x, right? Yeah. X over 2 is x times 1/2. With the negative sign in front of it, it's negative half times x. Yeah, times x. 8 over, yeah, negative 2, negative half times x, and bring down this term. 8 over 2 is 4, right? So it's minus 4. Minus 4. You see that? Yeah. So if you just take it even just 10 minutes, repeat the same process, you will be very good at it. Believe me, just 10 minutes. So you bring x over, that's very good. And you divide everything by 2, right? You didn't divide this by 2. You forgot that. Yeah. You have to treat everybody in the equation the same way. Yeah, this step is awesome. It's good. You bring x over, you change the sign, right? And in order to isolate the y, you need to get rid of 2. So you divide by 2, divide by 2, and divide by 2. Everybody divide by 2. Remember, equation is a scale. Whatever the treatment you apply on the left, you have to apply the same treatment on the right. Every single one. Yeah, negative x over 2, yeah. So that actually is negative half, negative 1 over 2 times x. Negative 1 over 2 times x. Very good. Do you see why? Because x over 2 is 1 over 2 times x. Like this. Right? And you switch the order. You just need to repeat. You have the answer. Very good. Perfect. Sammy, do you have an answer? Where's your work? You are isolating y. You are isolating y. Let's look at this problem together. Where's my pen? Okay. This is a stylus, right? Stylus, not pen. We are isolating y on the left. We need to get rid of this x, right? How do we get rid of this x? We can move it over. Do you see what happened in this step? Huh? Do you see what happened in this step? You bring x over to the right-hand side. So you have a negative x on the right-hand side, right? Do you understand that step? And to isolate the y, you have to get rid of the coefficient 2. So you're going to divide everything by 2. Divide this by 2, divide this by 2, divide this by 2, right? You have to treat everybody in the equation the same way. Yeah. On the left, 2 over 2 is 1. So we have a y isolated. On the right, we have a negative x over 2 minus 4, right? How do you understand the coefficient of x here? X divided by 2 actually is x multiplied by the reciprocal of 2, right? So that is a half times x. So on the right-hand side, the first term actually is Negative half times x. Do you see that? Yeah, your answer, that's your answer. Make sure you know how to get there. And tell me please, what's the slope? What's the slope? Huh? The formula is y equals mx plus b, right? What's slope m? Negative half, right? What's the y-intercept? 0, comma, negative 4, all right? All right, do you have any question about this example? We convert the equation, which is in the standard form, to its equivalent slope-intercept form. To do that, we are able to identify slope and y-intercept. Okay, next example, we are going to work on continue with the 3 problems in the 3 equations in example 1. We are going to graph the equation or the straight line by using slope and intercept. So example 2. That's example 1. So example 2. We are going to graph straight lines by using slope and y-intercept. So we also have 3 equations here. The first equation is y equals negative 3 over 4x plus 9 over 4. All right, I'm going to show you how do we graph the straight line by using slope and y-intercept. And this is the equation we got earlier in example 1. We know the slope. Slope m. Slope is negative 3 over 4, right? Y-intercept is 0, comma 9 over 4, right? Yeah, so let me show you. How do we graph the straight line? By using its slope and a y-intercept. In a rectangular coordinate system, we plot y-intercept first. So step 1. Yeah, make sure you are taking notes. Step 1, plot the y-intercept. Yeah, what's the y-intercept here? What's y-intercept here? 0, comma 9 over 4, right? Okay, can you convert 9 over 4 to its equivalent decimal? Can you help me to convert 9 over 4 to its equivalent decimal? 2.25, very good. Okay, that could help us to plot the y-intercept. Where is the y-intercept? Y-intercept must be on the y-axis, right? Yeah, below or above the origin? Below or above the origin? Where is the 2.25? It's right here, right? 2.25 is 2.25 unit above the origin. Does that make sense? Okay, that's the first step, all right? Second step, write slope as rise over run. Let me explain what do I mean, okay? Yeah, so your slope in this case is negative 3 over 4, okay? Your slope in this case is negative 3 over 4. You're gonna write the slope as a fraction or as a quotient of 2 integers, okay? As a quotient of 2 integers. You can write -3/4 as -3/4 or 3/4, right? Yes or not? Okay, so you can either use this one or this one. It doesn't matter. Either way would work, okay? Yeah. You write the slope. You write the slope as the quotient of two integers. Then you would have the rise and run. Yeah, this step is very essential, very important. You write a slope as a quotient of two integers. In this case, we have two ways to write a quotient of two integers, right? -3/4 or 3/4. And you tell me, do you want to use the blue one or the green one? Do you want to use blue one or blue one? It doesn't matter, okay? You tell me. Saria, do you want to use blue one or green one? It doesn't matter. Green, okay. Let's use green. So with the green, we have 3/4 equals rise over run, right? And tell me what is the rise and what is the run? What is the rise? What is the run? 3/4 is the rise over run. Well, rise over run is 3/4. What is the rise? 3, yeah. What is the run? -4. Awesome. Yeah. So step two, you are going to write a slope as a rise over run. Identify what is the rise, what is the run, okay? And how do you use the rise and the run? Step 3. Start from the Y-intercept. Rise and run to locate the second point. Okay? Yeah, so we start from the Y-intercept. We have this Y-intercept here already, okay? We're going to start from the Y-intercept. We got it in step 1. We are going to rise and run to locate the second point. What is the rise again? What is the rise again? 3, right? Rise is a positive, means we go up or go down. Think about it. If rise is a positive, so we go up or go down. Up, yeah. So from the Y-intercept, we go up 3 units. 1, 2, 3. What is run? -4, right? Run is -4, so are you going to the right or going to the left? To the left, right? 4 units. 1, 2, 3, 4. So this point is the second point. Do you see what I'm talking about? Yeah. You start from the Y-intercept. You rise and run. In this case, we're going to rise 3. 1, 2, 3. And run -4. Since the run is negative, you go to the left 4 units. 1, 2, 3, 4. So the second point is right here, right? You know, 2 different points determine a straight line. 2 is enough. Yeah, 2 points are enough for us to graph the line. And we're going to connect them together. And that's the graph of the straight line. What's the slope again? What's the slope of the equation? Negative, right? Yeah, is the line going up or going down? Going down. So when you take the test 3, which covers chapter 3, if you are looking for the graph for a given straight line, if you see the slope is negative, please do not choose the straight line going up. Okay? Yeah. We had this conclusion covered earlier. All right, you're gonna practice the second. Hold on, let's make a summary here. How do we graph a straight line? By using slope and Y-intercept. We have 3 steps, right? Step 1, plot the Y-intercept. Step 2, write a slope as rise over run. Identify rise and run. Step 3, Start from Y-intercept and rise and run to locate the second point. Yeah, I want you to look at this example and graph this line. Y equals -12x plus -4. Graph this line. Take your time. Y equals -12x minus 4. Can you tell me what's the slope? What's the slope? Yeah, -½. What's the y-intercept? 0, -4. Yeah, take your time. Use the slope and the y-intercept to graph the line. Are you expecting a line horizontal or vertical or go up or go down? What kind of line you are expecting? Down, yeah, because the slope is negative, right? Okay, take your time. What do you do first? What's the first step? Plot y-intercept, right? Yeah, please do that first. Can you tell me where is the y-intercept? Going up or going down? Going down 4 units, right? 1, 2, 3, 4. This is the y-intercept. What's the second step? Second step, you're gonna find your rise and run, right? And tell me what is your rise and run? How do you choose your rise and run, everyone? You can write slope as a -1/2 or 1/-2, right? It doesn't matter which one. How about this time? Let's choose this one, the blue. If we let the slope be -1/2, what's the rise? -1, yeah. Your run is +2, right? Okay, so from the Y-intercept, rise is -1, so we go up or go down? Go up or go down? Go down. Go down 1 unit, right? Run is a +2, so we go to the right or go to the left? Go to the right or go to the left? Right, yeah, right is a positive, so go to the right. 2 units, 1, 2. So the second point is right here, right? Yeah, sometimes you want more points, you can continue, you can keep doing the same thing. From the second point, you can go down 1 unit, go to the right 2 units, and you will have the third point. And if you have extra time, you can keep doing so until you have enough point and you feel comfortable to graph the line. Yeah, go down 1 unit, go to the right 2 units. Yeah. So once you have enough points, you can connect them. And that's the straight line corresponds to the given equation. All right. So today we completed slope of equations. That is 3.3. And we also covered 3.4, slope intercept 4. I'll see you tomorrow, guys.